The most faraway thing ever set by people. This is the first interstellar spacecraft that we made. Get ready for an interstellar shortcut that will keep you on the edge of your seat. Imagine launching a spacecraft or two 5 years ago, only to have them keep exploring areas that were never meant to be explored long after their expected lifespan. That's the mind-bending reality of a daring NASA mission that's changing the rules of space exploration. NASA's first of its kind. In 1977, scientists made a major discovery that has raised their standing and gotten the attention of people all over the world. It was 1965, the start of the space exploration era, and Gary Flandreau, a brilliant mind at NASA's Jet Propulsion Laboratory, had the huge job of figuring out the best way for a space probe to get to the furthest star: Jupiter, Saturn, Uranus, and Neptune. All he had was a pencil, which was a favorite precision tool of engineers in the 20th century. He realized that in the late 1970s and early 1980s, all four gas giants would line up in a cosmic dance, forming a celestial necklace with Earth. This once-in-a-lifetime event meant that a spacecraft passing by each planet would gain speed from their gravitational pull, like being pulled along by an invisible force. Flandreau figured out that a trip from Earth to Neptune, which used to take 30 years, could now be done in just 12 years with the help of gravity. But there was a catch. This pairing doesn't happen again for another 176 years. Flandreau didn't want to miss out on such a great chance, so he set out to finish the trip. Within a minute and 15 days of each other, NASA quickly got to work. They sent out two spaceships, called Voyager 1 and Voyager 2, that were the same. In the summer of 1977, they wanted to take advantage of the way that the stars were aligned, but they had no idea that these twin explorers would go on to break all records for space trips. Voyager 1 and Voyager 2 are still going strong more than 45 years later. Every day, they send back new and important information from the furthest parts of our solar system. They have been in space longer than any other craft in history and have gone farther than anyone could have dreamed. Even though their original goal was only supposed to last 4 years, they were able to do a lot in that time. They had a few surprises up their sleeves. Early on in their epic journeys, they gave us amazing up-close views of Jupiter's and Saturn's moons, showing us a world that was far more busy and alive than anyone had ever thought. With their discoveries of active volcanoes and measured ice fields, the Voyager spacecraft went above and beyond everyone's hopes and changed the way we think about these very remote places. It is the only spacecraft to have taken this kind of trip so far. It surprised physicists with amazing discoveries in uncharted territory over 14 billion miles from home. These pioneering interstellar probes are larger than big wagons and have defied expectations and continue to push the limits. Voyager 2 broke new ground in space. In 1986, it was the first ship to get close to Uranus, and just 3 years later, it was the first to go past Neptune. It took a lot of tries and 10 minutes of mistakes for the beat to be perfect. But the epic journey started with a move that had never been done before by a spaceship on its way to Mercury with the help of gravity from Venus. This made them pioneers. The first part of their trip to Jupiter took them 10 times farther away from Earth than Mercury and through the old asteroid belt, which had been the subject of a lot of talk and discussion before. In the 1970s, 19 and 11 went through the asteroid belt, which was thought to be dangerous, without getting hurt. This made the way for Voyager. Voyager's problems didn't end there, though. Its computers only had 69 kilobytes of memory, which is the same as sending and receiving messages with radio waves that moved with the speed of light. But the huge distance from Earth, which was getting farther by 3 or 4 light seconds every day, made it hard to stay in touch. It took more than 18 hours for Voyager 2's signals to catch up, And as radios, TVs, cell phones, and other noises from Earth got louder, it became harder to hear the "bank you" whispers from the ship. Planned for a gathering of like-minded things in the sky, held together by the sun's name and stretching halfway to the nearest star. Interstellar space with solar power is a more accessible frontier. The heliopause, the boundary between our solar system and interstellar space, marks the beginning of uncharted territory. Before the travelers reached the heliopause, their first guesses about how far away it was were all over the place, but they thought that it was somewhere around 50 astronomical units. Thank you for giving more money to the project. However, once the spacecraft left this landmark, scientists didn't see any signs of the expected science of interstellar travel. One of the signs that a star had moved into interstellar space was a rise in galactic cosmic rays. These are high-energy particles that are thrown out of supernova and other cosmic disasters at almost the speed of light. Whoever's at most low-energy cosmic rays are turned away by the hemisphere's huge magnetic shield, which also keeps most outside threats away from our inner solar system. As the Voyager probe went deeper into interstellar space, the Voyager team kept a close eye out for any changes in the magnetic field that was the strongest. This was because it was thought that the magnetic field of the interstellar medium, which is made up of ionized gases and is affected by close stars, would be different. It was thought that the direction of the magnetic field would change whenever there was a change from an area where the Sun's magnetic field was the most important to an area where the magnetic fields of other stars were more important. In November 2018, Voyager 2 began its long trip to the edge of interstellar space. It reached the heliopause, the edge of our solar system, at 130 astronomical units, the same distance its twin had reached 6 years earlier. Scientists were confused, though, by the fact that Voyager 2 didn't find any changes in the magnetic field, and new theoretical models only added to the mystery. The 11-year cycle of the Sun should affect the heliosphere the same way it does the solar wind, according to estimates. But none of them could explain this difference because the solar wind was at its strongest when Voyager 2 arrived, which means that the heliopause should have been further away than 128 astronomical units. Also, as the Voyager probes get closer to the interstellar medium, their data shows interesting directions on a smaller scale, but at a very large scale. Some scientists think that the Voyagers could still be in the heliosphere, but others are convinced by the big increase in cosmic rays and plasma density reported by the probes, which points towards the majority position. We need an interplanetary approach to shed light on it from the outside. Some technologies, like answering machines and pennies, have become obsolete. But trying to solve one of the heliosphere's most basic mysteries from the beach is like trying to see a gold mine from the beach. With their old ways of doing things, the Voyagers are still dividing the chances. These spaceships are run by technology that is 50 years old. They don't need much software to be controlled, and the person who made them couldn't rely on complicated lines of code. All of the working instruments on Voyager 1 and Voyager 2 are driven by a process that turns the heat from plutonium radioactively breaking apart into energy. But NASA has had to switch to an emergency mode because the Voyager's power output is dropping by about 4 watts a year. Now, Voyager 2 has 5 sensors that work, while Voyager 1 only has 4. It's been 3 years since mission engineers had to turn off the heater for the cosmic ray detector, which is an important tool for figuring out the heliopause passage. Even though everyone thought the instrument would break, it kept working at a truly amazing beat even when the temperature was much higher than what it had been tested for. Because they are inside the spacecraft's main body, the magnetometer and the plasma science device are likely to be the last ones to shut down. Power is the real game changer. It's the deciding factor, even though the Voyagers will keep going even when they hit problems, which could take up to 16,700 years. If everything goes as planned, scientists might be able to keep going on their trips until 2030. Voyager 1 will pass by Proxima Centauri up to 3,600 years after Voyager 2. After that, they will continue to orbit the galaxy for millions of years. This means that long after our Sun has died and the heliosphere has disappeared, these hardy spacecraft will still be there, unlike our little blue planet. They may even send a final message at some point, but it won't be sent over radio waves. Voyager 2 will go by close by. The story of the Voyagers is still a tribute to human discovery and the scientific curiosity that pushes the limits of both time and space. Thank you for watching this video.